So thank you very much, everybody. I'm Debbie Moran. I'm the novice chair, and I always tell people I joined the club out of college, and I learned pretty much everything I know about observing, being a member of the Houston Astronomical Society. So welcome, everybody. It may look like our scheduling Jupiter is a little bit out of time. I did mention the people ahead of time, just in case you're late night observers, that Jupiter's opposition, which I'm sure Chris will explain, was on September 26th. So that's when Jupiter was closest to us. But sometimes the best time to observe is a little past opposition if you're not a late night person. So we are now in the period of time where we'll be starting out with Jupiter. As it gets dark, will be higher in the sky, and that's always a better time to observe planets. So I asked Chris Morisette this time to talk about Jupiter, and he's like a mega member of many of the clubs. So we are the Houston Astronomical Society, but we also have some smaller clubs in the outskirts of Houston, and Chris is a member of at least two of those, the North Houston Astronomy Club and also the Fort Bend Astronomy Club to our southwest. So do feel free, if you're a new member, to join multiple clubs, if that gives you a little bit more opportunity to learn. And Chris is also a member of the McDonald Observatory Board of Visitors, and sometimes a volunteer at the George Observatory. So in honor of this talk, I put my Jupiter on my top shelf instead of my third shelf behind me. And by the way, I found that in an estate sale. It lights up. Apparently doesn't show up lit up on Zoom, but it's the best $6 I ever spent. I've got a Mars, a Jupiter, and an Earth. So without further ado, Chris, please take it away.
Fantastic. Thank you for those kind words, Debbie. And let me share my screen. There we go. Excellent. All right, great. Well, listen, welcome, ladies and gentlemen. I'm Chris Morisette, and I'm delighted to present Jupiter tonight. Very timely topic. It's in kind of prime time viewing, and really going to be some neat material covered tonight to help you view Jupiter. I'd like to start out the presentation with a beautiful image by Andre Salaveria. He's one of our members. And this is a picture of Jupiter in opposition last year, August 16th, 2021. And just a marvelous image. And I'll be featuring images from club members throughout the presentation to help explain things. I'm going to break up the topics tonight into four general categories. Talk about viewing, kind of get right into the brass tacks of what we're here tonight to discuss, so that you can get out there and do some great viewing of Jupiter. We'll talk about planetary details and more about the composition of Jupiter, its moons, its atmosphere, all that kind of stuff. I'll then touch on some historical significance of Jupiter, how it played a role in the history of astronomy. And then we'll wrap up with a brief image acquisition primer on Jupiter that Sonny Manley kindly made available to me. I can't promise you I'll turn you into astrophotographers tonight. As a matter of fact, I'm having trouble turning myself into an astrophotographer, but at least I'll get you started. And it is a kind of a nice segue into tomorrow's presentation on EAA. So let's get into viewing. First thing you'll want to do, if you haven't already, is to go grab a copy of the October sky map to give you a guide when you go out into the field to go look at Jupiter and Saturn and other objects in the sky. Jupiter is currently right here on the ecliptic, kind of in east-southeast rising, and in Saturn ahead of it there. Another view of this would be like so. I made a screen capture off of Sky Safari. This is actually 10 o'clock tonight. And again, you'll see Jupiter rising in the east-southeast. It's in the constellation of Pisces. And it is, primetime viewing this time of year with respect to its position in the sky. So why now? As Debbie mentioned last month, Saturn was in opposition in August, the 14th of August, here almost a couple of months ago. And Jupiter was actually in opposition, a week or so ago. So we're right at prime time viewing for Jupiter. So what does opposition mean? So opposition means that, let me see if I can get rid of there. There we go. Opposition is really the position of Jupiter when it is closest to the Earth, and when it is kind of closest to the Earth at the middle of the night, as opposed to dawn or dusk. This is good for a couple of reasons. Number one, it's close, so we can see a larger image of Jupiter, as well as it is up above us, kind of at the zenith, so to speak, so that when we view Jupiter, we're looking through less atmosphere. Of course, in the morning and the evening, it's at a lower position on the horizon, but primetime viewing at night, it's in a really advantageous position. Okay, let's get to the next slide, shall we? Okay, please help me out. Okay, well, darn it. I cannot get this thing to advance.
Not advancing, Chris?
It is not. I don't know if it had anything to do.
Try stopping the share and then resharing again.
Yeah, let me do that again. Apologies, folks. Let me. Oh, here we go.
And while we're waiting on that, I was just going to remind everybody that if you have any questions for Chris throughout the course of this conversation, this discussion, please use the chat feature that we have in Zoom. Put your questions in there, and we'll get to those at the end of the presentation tonight.
All right. Okay. I think we're in business, Joe.
Perfect.
All right. So, getting back to what I was just mentioning, given our position in the orbit of the sun and Jupiter's position, we're able to see Jupiter as a much larger object in the sky due to its closeness. This slide right here gives you a nice comparison between opposition, which I think is on the right-hand side here, versus when you would see Jupiter at another point in time in the year. In addition to size, the magnitude of Jupiter will also be lower, which means it will be brighter. Let's talk a little bit about retrograde motion. Retrograde motion is the motion the apparent motion that a planet will make, specifically Mars, Saturn, Jupiter, will make in the night sky as our paths, our orbital paths, run across each other. So if you think about the orbital paths around the sun as like the tracks in a track meet, and we've got the inner track. When we're coming up on Jupiter, it looks like it's out ahead of us, but as we get close to it, it appears to stop, and as we pass it, it appears to go backwards. And it's just the relative motion of the planet to Earth. So that's what retrograde motion is all about. And that's what we're in the middle of right now, is Jupiter's in opposition. I apologize for the fine print on this particular map, but this is a pathway of Jupiter from March 2022 to June 2025. And the areas of the map that I have circled in yellow represent the period of time in which Jupiter is in retrograde motion. And it's happening right now, and then next year it will be occurring roughly September-ish, October-ish, and then into April and February, so on and so forth. And then on the upper left-hand corner is the period of time when Jupiter will be in opposition in the 2024-2025 timeframe. So let's talk a little bit about equipment for viewing. Jupiter is a relatively small object in the sky, so magnification is a necessary feature. for the equipment that you use to go look. Now, for visual astronomy, I personally use binoculars. And binoculars, to be honest with you, are really not suitable for this object. Although I can see the moons of Jupiter, but I can't make out really any other details other than the moons. So if you're going to go look at Jupiter, you really want to, in my opinion, you really want to consider starting out at diameter of 6-inch diameter telescope and larger to be able to get the magnification that you want. And this right here is a wonderful looking refractor from Takahashi, and I'm sure that is a beautiful instrument for taking astrophotography. You'll also can use Schmidt-Cassegrain type telescopes. So Celestron makes a series of Schmidt-Cassegrain telescopes. I think this, what you see pictured here is a Celestron, and they'll come in 6-inch, 8-inch, 11-inch, 14-inch. Those are very nice telescopes as well for viewing Jupiter and can give you the magnification that you want. They can be a little bit pricey, but they are a nice piece of equipment. For those that may be more cost conscious, you get a lot of bang for the buck with the Dobsonian Newtonian telescope. You can get a lot of diameter for the buck when you get into this style of telescope. You can't track in that well, at least not out of the box, but you can move the scope around and get some really wonderful views of Jupiter with this piece of equipment. One thing to remember is the eyepiece in many cases is as expensive or more expensive than the telescope, but you want a quality eyepiece so that the whole visual train that you've got here is giving you a quality image of Jupiter. This is a nice comparison here to kind of give you an overall idea of telescope diameter versus what the size of Jupiter would look like, and say maybe the largest telescope that you may be using. So along the bottom here, what you're seeing here is kind of a baseline of Jupiter using an 18-inch diameter telescope. And then along the top, you're able to see a comparison of, hey, what would I get with a 3-inch, a 4-inch, a 6-inch, an 8-inch, so on and so forth. And as you can see, as the diameter of the telescope goes up, you're able to get a much larger view of Jupiter. One tool I found online that I found useful and I'd like to make you aware of, there's a website called Astronomytools.com, and in that website they have a feature, a function in there that will allow you to input your telescope specifications, your eyepiece specifications. You're able to select Jupiter and then push a button. And what it'll do is it'll give you kind of a picture and a framework, a field of view, if you will, of what Jupiter would look like with a particular telescope configuration. So if you're wondering for your particular rig, hey, what will Jupiter look like? Do I need to look into maybe getting a Barlow or something like that in order to increase the magnification? This tool is a quick and easy way to kind of ferret that out. Magnification, in addition to depending on the aperture, also is very dependent on the seeing conditions. And we're looking at Saturn here. Obviously, I tried to find a equivalent picture with Jupiter, but no such luck. I think the point here is you can magnify the image up with your telescopic, with your visual assembly that you've got, your telescope and your eyepieces. However, if seeing conditions are not, if they're turbulent, if you've got a lot of movement, motion in the atmosphere, that magnification may not pan out for you. And you can see this image over here on the right is very fuzzy and not very quality. So seeing conditions are key in terms of being able to get a nice view of Jupiter. And so what is seeing more specifically? So when you're looking at the horizon versus directly above your head, you're looking through about 40 times more atmosphere than you are when you're looking directly up. And as a result, you've got more material to look through and more potential to distort your view. So opposition is important, and it's a nice time to view the planet is because, again, it's right above us overhead, and it allows us to look through the least amount of atmosphere that we need to. Another thing to consider too is having a temperature inversion, which Houston is famous for, actually is a good thing, because when you have warm air overlaying cooler air, you're going to get a more stable situation in the atmosphere, which again will allow you to get a more quality view of Jupiter. And the other thing too is you'll want to avoid the night after a cold front for looking at Jupiter. I mean, you could look at Jupiter, but if you're going to be going out doing anything, with respect to maybe some photography, or if you really were going to get down and dirty with a lot of intricate viewing of the various features of Jupiter, you might want to avoid these nights because you get a lot of turbulence up there, even when you're looking up, directly overhead. And again, that's going to disrupt your view. So, waiting a night or two for better viewing is a good idea. And this time of year, obviously, we're going to be getting some cold fronts through here, so it won't be uncommon. Another thing to consider here too are filters. Filters can make a difference regarding the detail that you want to see on the planet. So filters are another key piece to your optical train, so to speak. And as you can see here, eyepieces typically come in 1 1/4 or 2 inches. Make sure you know which one you have so that when you buy your eyepieces, they're going to fit. This is a nice little summary of color filters in the areas of the planet that they can enhance. I just briefly go through a couple of these. So light yellow will help enhance the belts, which are the dark zones along the circumference of the planet. Yellow will help with the red areas and the blue festoons, which we'll talk about here in a little bit. Festoon referring to the kind of the daisy chain cloud covering that you can see. Orange is great for the red spots, the great red spot rather, and so on and so forth. This next chart is really a nice reference, and I'm hoping that this presentation can be made available to the membership, because this chart is really a handy reference. This really gives you an overall view or overall understanding of what filters there are out there and what filters will what features on Jupiter will be enhanced by using those filters. Now I'll switch gears a little bit, talk about transits, shadows, and occultations. And again, this image right here, this animation was done by Sonny Manley, and he did this here a week or two ago on September 22nd. And what he's showing in this animation is the transit of both the moon Europa and its shadow. And we'll talk a little bit more about shadows as well. One of the things about viewing Jupiter that I didn't appreciate till I really kind of dug into the subject. You might think that Jupiter is kind of a static thing. You see it once, great, I'm done with that. But Jupiter's very dynamic. There are a lot of things going on, not only with the atmosphere, but with the moons, occultations that Jupiter may experience with our own moon. So while you've seen it once, there are different situations that you can see it in, and that's kind of the neat thing about Jupiter, which makes it really interesting. This first diagram here that I want to show you is a depiction of the sun rays coming from, the sun, obviously, and striking the moon Ganymede, and in doing so, creating a shadow on the surface of Jupiter. So you can see right here that shadow. Now, we're looking at Jupiter from a somewhat offset position. And as you can see, we're going to have a view in this particular situation of the shadow, but Ganymede may actually be off to the side of Jupiter in space. So while a moon can transit the surface and the shadow can transit a surface, they don't necessarily happen at the same time. And that's really the point that I'm trying to illustrate here with this diagram. This next image here is a transit of Io on Jupiter, and I think it's on the 27th of September, but the little Zoom thing is blocking that out, so I can't swear to it. But this is again another image by Andre Solivaria. He was kind enough to give to us for the presentation tonight. And in this particular case, in this particular instance, you can actually see Io and its shadow. And Io is this bright object right here, and then the shadow right here. As Io was, and I'm guessing, but as Io was crossing closer to the center of Jupiter, you probably couldn't make it out that well, just because of it would tend to blend in with the surface of Jupiter. But in this particular case, you're getting a little bit of shadow or a little bit of contrast there on both the moon and the shadow. This is a very illustrative image to kind of show you the transit of both the moon and the shadow. This next image here is a shadow transit of both Io and Europa that was captured back in March of 2016. And this was captured by Lloyd Overcash, who recently departed us, unfortunately, but his astrophotography lives on, and I'm proud to show Lloyd's picture here. But you can see two shadows transiting the surface of Jupiter, which again, I think is really cool. You know, again, you say to yourself, you know, what more can Jupiter give me other than just going out and looking at it once? Well, there are a lot of different situations that can crop up here and that are really cool to observe and really neat phenomena. And then this last picture here shows a really unique picture. This is from an individual from Belgium. And you can see in this picture the transit of three moon shadows, and off to the left you can see the three moons themselves. So this kind of goes back to that diagram that I showed earlier, where you don't necessarily have the moon and the shadow transiting at the same time. So very, very cool picture. Very, you know, and again, really neat objectives to kind of go out and look at when you're observing Jupiter during this period of time. Excuse me. This next picture here is a partial occultation, and an occultation is really a situation when one celestial object, like our moon, hides or hides from view another celestial object like Jupiter, like a star, like, you know, you name the star, like Pleiades, things like that, like, you know, different objects that are in the night sky. And this one shows what they call a grazing occultation of Jupiter. And it's neat. You've got Jupiter with our own moon, and it makes for a very interesting picture. And you can actually follow it with video and actually see the entire eclipse, if you will, of Jupiter. So very interesting situation here. Okay, so that's a little bit about viewing. You know, we covered the type, you know, where you can find Jupiter, where it is in the night sky, what kind of equipment are you going to need to look, and then once you've got all that together, you know, what should I be looking for? So hopefully we've given you some good information there to help you with your viewing journey of Jupiter. Let's dig into some details about the planet, because aside from being cool to look at, Jupiter's got a lot of neat features. So here And this was Debbie's suggestion, and I'm glad she suggested it because these pictures are really neat. These are the recent, I got a couple of slides here that show the recent Webb telescope images, and they're truly amazing. Now, I just want to say a few words about the image itself. So this was taken with the near infrared camera that's on the Webb telescope, and it's showing, or it's imaging wavelengths of radiation that are right at the border of infrared and visible light down into the infrared spectrum. And of course, infrared light is invisible to us. So the data that they captured here with this camera, they've actually mapped onto a visible light spectrum so that we can see it. The longest wavelengths that you see here appear redder. So these are the longer wavelengths of data that they collected. The shorter wavelengths appear more blue. So that's what you see here in these belts right here. And then the brightness indicates the altitude of the atmosphere that they're photographing here, or they're collecting data on. So you'll see here that the big red spot is actually the big white spot here in this picture. But what that's telling us is that the altitude of the clouds in that particular region of Jupiter are at relatively high altitudes. We can see a lot more detail with the infrared imaging, and I think I got this right, but I'm sure if I don't, somebody will help me out with that. But since infrared light can pass through and show us things that would generally obstruct visible light, we're able to get more detail with it. And I think that's the key thing here in this picture. This next one is really a cool picture. This shows a couple of wide field views of Jupiter, again from the Webb telescope using the near infrared camera. And because we're able to see through dust and debris and other obstructions that would obscure visible light, we're able to make out the rings on Jupiter. Jupiter actually has rings, similar in not as elaborate and as spectacular as Saturn, but it does have rings, and you can see that here. It also has a very prominent showing, if you will, of the auroras on the northern and southern poles. So that's really kind of neat too. They show up really nice and brightly. There's a couple of small moons over here. Almathea and Adrastea. I think I got those names right. That show up. Jupiter has the 4 Galilean moons, but it has a multitude of other moons as well. And then the last thing I'll show you on this picture are some very faint patches of light down here, here, and here, and those are actually galaxies. So again, it's a very colorful, beautiful pictures that we're getting from Webb, and very timely that we're able to share that in this presentation tonight. A little bit about Jupiter in context. It is the largest planet in our solar system. It's about 317 times the mass of Earth, approximately 12 Earth diameters wide. So very large planet from a size standpoint. It is about 484 million miles away from the sun. And it has an orbital period around the sun of about 12 years. Jupiter rotates relatively quickly, so while a year takes a long time to complete, a day is much shorter than a day here on Earth. So a day on Jupiter is about 10 hours long. And this animation that you see here from Mr. Don Parker kind of illustrates that. You can see the red spot up at the kind of right up in this neighborhood right here, passing by very quickly. This is another picture that kind of gives you an idea of what's happening on Jupiter in terms of its daily rotation. So on the picture on the left here, you see the red spot is right in this position. And then about 30 minutes later, it's actually moved position, materially moved, so that, you can see and notice that it has moved. Again, another cool thing to do when you're out looking at Jupiter is to try to measure and look at the movement of the atmosphere and of the red spot. And the red spot is a great target because it's very, very visible, and it will move with the rotation of the planet. So another objective for viewing out there. The composition of Jupiter is mainly hydrogen and helium, and that's typically what you'd find in a star. And that's why I think Jupiter's been referred to as a failed star, because it just didn't have the conditions to set off a thermonuclear fusion to do what a star typically does. But it's mostly hydrogen and helium. It has a metallic hydrogen core, and it has, and this is kind of a cool thing I got off of this one picture, it has helium and neon rain. So when I heard that, I heard the Prince song Purple Rain in my head for some reason. I don't know why, but I want to see neon rain one of these days. Here's an early sketch of Jupiter back in I'd say early sketch, back in 1872. I guess anything before my birthday is early. So 1872 is early. And this individual created what he called a festoon sketch. And the festoon refers to, festoon can be like a daisy chain of flowers or ribbons and things like that. So he used festoon here in this context to kind of describe the cloud cover that he saw around the midsection of Jupiter. This picture right here gives you a kind of an overall view of the zones and belts in Jupiter. Excuse me. And so a belt is actually the dark colored bands of clouds right here. And the zones are the white colored areas of clouds. The zones are thought to, so the zones are going to be areas where atmosphere is ascending, rising, and then the belts are areas where atmospheric material is descending down into towards the center of the planet. And anyway, that's a kind of a nice representation of the different areas of atmosphere. Here's another picture of the regions and belts along with the polar north and south polar regions. But again, it just kind of a nice depiction to kind of map out, if you will, what the various sections of the atmosphere look like. And these bands and of clouds are in flux. So that you see with this animation, we're actually seeing clouds move across the circumference of the planet. You can see down here the red spot is swirling and moving in the opposite direction. Kind of reminded me of hurricanes here on Earth. I'll talk a little bit more about that here in a second, because this atmosphere is dynamic and changing. This is a flatter image of the same type of situation. And again, it gives you a little bit more clear picture of the atmosphere and how dynamic it is on Jupiter. The other thing, too, is that these atmospheric structures on Jupiter are dynamic. They are changing. So you see in this particular picture, you'll see the band, or one of the belts, rather, has faded dramatically, almost to the point where it's disappeared. And so if you think about our own atmosphere on Earth, we experience storms and hurricanes. So somebody looking in on Earth would notice that our atmosphere is in flux as well. I think the difference here is that the storms and the atmospheric structures on Jupiter are probably longer lasting than what we see here on our planet. Here's another picture that kind of focuses in on the ovals. So the Great Red Spot is an oval. I didn't know we had a red junior, but I did learn that as a part of getting prepared for this presentation. But in addition to the zones and the belts, you have these ovals, which I kind of tend to think of as storms, since they're circulating like a tornado or a hurricane. And these storms can collide and actually merge into one larger oval or storm. So here, this picture here shows a situation where you had three distinct ovals, and then over a period of about 3 years, they had merged into one larger oval. So again, dynamic atmosphere, ever-changing atmosphere. Here are some pictures that came from Voyager 1 that are very cool. So this kind of gives you a closer view of what these clouds look like, what these ovals look like. They're very, very dramatic, very beautiful. This one shows you kind of that festoon shape or that festoon pattern that the individual identified back in the late 1800s and depicted in his sketch. You can see like the nice daisy chain of clouds down here, which is really, really dramatic. And then this last one here is a picture of the Pearl Storm. And again, this is a image from Juno. It was enhanced. And this one, oddly enough, when I first looked at it, reminded me of a painting by an impressionist artist. You know, you kind of get those bold strokes, brush strokes and textures. And that's what this reminded me of. But what we're looking at here is the surface of Jupiter. So pretty amazing. As you can imagine, with this much movement and motion in the atmosphere, they probably have some pretty sizable winds. So the average wind speed on the surface of Jupiter is, in the 200 to 400 mile per hour range. The Great Red Spot actually has winds that are in excess of 400 miles an hour, and the wind speeds there are actually picking up. And then in the polar regions is where you have the highest wind speeds, and they're around 900 miles per hour. So, even faster up there. But some very horrific wind speeds. Now, Jupiter is a terror to a lot of celestial objects out there, namely asteroids and things of that nature, due to its sizable gravity. But while that's a bad thing for objects like that, it's a good thing for us because it's kind of acting as a magnet or a vacuum cleaner, if you will, to clear out debris that might otherwise hit Earth. And if you think about it, in order for intelligent life to develop on a particular planet like our own Earth, you need a lot of undisturbed time for things to develop. And that's what Jupiter has kind of allowed us to do. It's kind of our blocker or tackler, if you put it in football terms, and it's clearing the way for the quarterback, so to speak, to make it through to the goal line. So Jupiter it's our friend. I guess that's what I'm trying to say here. And then one dramatic example of that is Comet Shoemaker-Levy, and I want to take a step back and just say, when you prepare for these presentations, you always learn something new. And this was it for me. I just was kind of fascinated with the story here. So Shoemaker-Levy, this comet was probably attracted to Jupiter sometime in the 1960s or 70s. It was like your typical comet that would, circle out from the Oort cloud and around the sun and then back out. In this particular case, it got trapped in Jupiter's orbit. And then in 1992, the comet was discovered, and it was actually orbiting Jupiter, which I thought was fascinating. I didn't realize that. As the years went by, in 1994, due to the gravitational attraction of Jupiter, it actually busted Shoemaker-Levy apart and then began to attract and absorb the debris into its surface. And again, act as that protector, if you will, for other planets in the neighborhood. So here are some impact scars that Shoemaker-Levy left. So you see these dark spots here, here, and here. Those are where the fragments of that comet actually impacted the surface of Jupiter. But again, a really fascinating story. I'll just love that when I run into stuff like that. Here are some other situations where debris was captured and absorbed by Jupiter. So you see here this white flash. Right here is an example of where some cosmic debris got sucked in by Jupiter. Here's another example where cosmic debris got sucked in and impacted the surface. So really neat stuff. Like to just pivot now and talk about the moons of Jupiter. I just saw an email out this afternoon about Europa, so I'll try and speak a little bit about that email and the news contained in that when I cover Europa. But overall, here's a kind of a comparison slide. Excuse me. Here's a comparison slide of Jupiter's moons in relation to our own moon, Earth's moon. Our Earth is about the 5th largest in the solar system, and I believe Titan, Ganymede, Callisto, and Io are bigger than our moon, and in Europa, and so on and so forth. But this just kind of gives you a general view of what the main moons of Jupiter look like in comparison to our own moon here. The inner 3 moons of Jupiter have resonant orbits, and that's not typical. Typically, when you have a resonant system, that system will act in a way as to get out of resonance. So, usually what you would expect is for these 3 moons to exchange momentum with each other and change their orbits so that they did not have resonance anymore. However, in this case, resonance is actually a stable situation, and because it has created a stable situation, stable orbits for these moons, it has a very long lifetime. So that's kind of an interesting thing. The one moon, Callisto, that's farther out is not part of this resonance, although I think it is part of another type of resonance with these other 3 moons. But that's what we got going on here with these 3 inner moons. So Io, the pizza planet, that's an interesting term. It is the most volcanic body in our solar system. And the driver behind this volcanic activity is the push and pull from the gravity of Jupiter versus the other 2 moons, Europa and Ganymede. Is the constant pushing and pulling and grinding and so forth of the surface and material in Io. It actually has lava. Let's see, what are they called? I think they're called, in this particular case, plumes, rather than, it's not lava, but plumes of sulfur and sulfur dioxide that will emanate from the surface of Io and go up to about 300 miles above the surface of the moon. So very interesting moon with Io. Europa. So cool story here. So Europa has one of the smoothest surfaces of any body in our solar system. It doesn't have any noticeable impact craters. It has no large mountain ranges or valleys like you would see, say, on the moon or our own planet. It's very smooth, and that has led to the hypothesis that there's, a cover, if you will, of covering a large ocean that there's a large ocean underneath the surface of Europa. And the email that came out today talked about life oozing on Europa. And again, I didn't have a chance to read it thoroughly, but it apparently, one of these splotches that you see here a new one had actually formed, and they could see material oozing out from that splotch. So there is with water, the hypothesis is you may have life on this moon. So anyway, I got to dig into that article a little bit more, but very timely article for the presentation tonight. And so that's Europa. Ganymede is the third moon out from the surface of Jupiter, and it has a fully differentiated makeup. And what I mean by that is that the core is liquid iron, and the rest is thought to be an internal ocean, perhaps water. So when I say differentiated, I mean they're actually phase separated, and they're two distinct layers, if you will. I think I got that right. So I looked, I saw that, kind of scratched my head a little bit, went back and looked again. So hopefully I got that story right. But that is Ganymede. And then the last one's Callisto. And Callisto is an interesting critter. Callisto is the most cratered, pockmarked object in the solar system. And it has, it's very heavily cratered, and it's a very the density of this is very low, so that's interesting as well. But anyway, cool looking moon. Not as interesting probably as Europa and Io, but nonetheless a cool thing to consider. So we talked about the planet Jupiter. I hope I've given you an appreciation for the makeup of the planet, its moons, its atmosphere. Very dynamic object out in our solar system. Now we'll talk a little bit about history. Galileo, who was the first astronomer to really utilize telescopes, he made some discoveries of Jupiter and its moons that really added and progressed the Copernican hypothesis that our solar system is heliocentric as opposed to geocentric. In other words, not everything's revolving around the Earth, but rather around the sun. And it's due to the fact that he witnessed the motions of the moons that provided evidence to further the Copernican thought on that. The church didn't like it, by the way, but as time took us down into the future, his observations have panned out. So this is a early depiction. This is a depiction of Galileo's journal, which doesn't really look too coherent, but this one's a little bit better. So what you see here is he has documented or is documenting Jupiter in the relative positions of the moons, the Galilean moons of Jupiter over different periods of time. So really fascinating observations there. And then this is another plot that he made, again, kind of a precursor to the sky and telescope diagram that you can look at in order to tell the position of the moons. And this is probably a depiction of what Galileo saw through his telescope when he was first looking at these moons. I remember the first time I saw this, I was blown away. I borrowed a telescope from the loaner program, took it out on the driveway, saw the moons, and almost did a visible. I just couldn't believe it. It's really cool. If you haven't seen it, you really need to. One last item of scientific or historical relevance, rather, for Jupiter. Jupiter played a role in determining that light has a finite speed. So a astronomer by the name of Ole Romer had actually witnessed eclipses of Io at different points of time in a year when we were at different distances from Jupiter. and had seen different times for those eclipses taking place. And from that, he deduced that the speed of light was finite. So another place in history for Jupiter. Okay, so last topic to wrap up tonight is a little image acquisition and processing. Again, another image from our own Sonny Manley. Appreciate that, Sonny. And Sonny had provided, I asked Sonny if he could kind of give us an overview, a thumbnail sketch of what he does when he images Jupiter. And he offered the following. So I won't go through all the nitty-gritty details here, but just in overview, imaging equipment. So Sonny, in his case, is using a Celestron 8-inch or 11-inch scope that he has. Again, kind of getting back to the equipment we talked about earlier. So kind of in the same range. He's got a one-shot color camera he's utilizing Barlow's. I personally thought Barlow's were more of a magnification tool, and they are, but he's also applying these depending on atmospheric seeing. He's using a filter and then a series of software packages to capture the image, to stack the frames that he's captured, to do some processing in both Registax and Photoshop. So from an equipment software standpoint, this is the kind of kit that Sonny's using to accomplish that. Getting down into data acquisition and processing, he's, one of the things that Sonny is saying is focusing is a main topic of focus, no pun intended, but focusing is key, and that seeing greatly influences how easy or hard it is to get proper focus. So this time of year in opposition, that gives you the best shot that you can get in terms of getting good seeing conditions. In this particular case, rather than taking individual images, he's actually taking a video anywhere from 30 seconds to 3 minutes, and then processing that video in AutoStacker and some other software packages, Registax and Photoshop. So again, don't want to go into too much of the nuts and bolts, but did want to give you an appreciation for the time and effort that went into capturing those images. And, the last thing here is that atmospheric seeing is just key in order to get a good image of Jupiter. So just wanted to share that with you for any potential or budding astrophotographers or people that are just interested. And again, some of this may be of value for tomorrow's topic of presentation, but wanted to share that with you. You can get more information about Jupiter. Got a few resources listed here, and I didn't add the Astronomytools, but make sure that you check that out as well. And with that, I'll just leave you with, hey, get out there and see Jupiter. It's a wonderful object, and I thank you for your attention tonight, and I'll be happy to try to answer any questions. So thank you.
All right, Chris, thank you very much. Fantastic presentation. I know we did have one comment kind of question from Bill Staziri in the chat. Bill, did you want to come off of mute and ask?
Yes, thank you. I found it very interesting that you said that Callisto is the most cratered object in the solar system, if I'm quoting you correctly.
Yes.
And I was surprised. I know it's got a lot of craters. I tried counting them. I didn't have enough time. No, it's got a lot of them. Anyway, I was always told that our moon has undergone what is called saturation cratering, which means that every square inch on it is a crater, and the only way you can make another crater is you're going to be obliterating one of the crater that's already there. So I sounds like 100% to me, and so I'm curious how they determine Callisto has more craters than that.
Yeah, that's a good question. I mean, the only thing I could say is, that is information that I got from a very cursory review of things like Wikipedia and, typical internet sources that I trust and use. So I can't swear to it, but I did see that. I thought that was interesting, and be happy to research it more and get back to the group on it.
Can I
Well,
say
thank you. I
something?
appreciate that.
Yeah, I don't know for sure, but the near side, we've got all those Maria. So if there were craters, they're kind of covered up. We actually have quite a few blank spots on the near side of the moon, whereas the far side is incredibly cratered. I'm wondering if Callisto is more like the far side of the moon all over. But we have quite a few uncratered areas, or maybe just places where the surface is too new to show up. Any craters on the near side of the moon with all the Maria, all the seas.
Well, yeah, I tend to, there are those blank areas on the near side, Debbie, no two ways about it, except that those blank areas are seas which fill a crater, right? There was an impact, it made a big crater, put a hole in the middle, the magma comes up and fills it up. And therefore, typically, I think the entire sea is a crater that just hasn't been impacted again. So you have a limited number of craters within it. I think that's the way I look at it anyway.
Yeah.
I'm for
like I said, let me do a little research on that, Bill, and get back to the group.
Thank you, sir. Appreciate it.
You bet.
All right. I see Renee had a question in the chat as well. Renee, do you want to come off of mute and ask?
Well, I was just supposing that perhaps is Callisto larger and therefore would have more room to have more craters. That's just conjecture.
Yeah.
So then it wouldn't be the percentage of it that's cratered, but just how many number of craters.
Yeah, I don't recall the actual, but just a guess.
So you're going to have to count up all the craters on both of them to know that, I guess. I don't know.
Well, I know you tried.
Yeah, well, that was maybe.
We'll get the telescopes out tonight and start counting.
And I heard that there's actually people using artificial intelligence looking at the maps of the moon to try to count the craters.
Wow, that would make sense.
Yeah, well, but that's because they have time on their hands to do this. I'm not exactly sure what the purpose of it is, but they're working on it, I guess.
Yeah, with machine learning, you have to be careful because if the models aren't right, I don't know if you've ever seen this, but those machine learning algorithms still have a hard time distinguishing between a Chihuahua and a blueberry muffin. And when you look at some of the photos, it's like, you know what? I can see why. All right. Did we have any other questions for Chris? You do, feel free to come off of mute and ask. Not Debbie, I think you said you had a final fun story as well.
I do, if nobody else has a question. Well, first of all, I'd love to thank Chris. That was a fantastic presentation. Really appreciate it. I think people are getting, it's really nice to have some other speakers. We're going to have yet another relief speaker next month, Craig Lamison, and I'm hoping for December to get maybe a panel together to discuss the experience of outreach and maybe get some of you others interested in outreach. I wanted to mention that sometimes a triple moon transit on Jupiter comes in handy. So a few years ago, I can't remember, it was 2016 or somewhere in there, we had a triple moon transit. Those are rare. They only happen every few years. And I was out in the front yard and there's nobody else around, no neighbors walking by to invite them, and found 12, a little after midnight, the third moon shadow comes on, and then I see the constable car come up, and they always wonder what someone's doing out in the front yard after midnight. So I went up there. There was a woman in there, Officer Rodriguez, and she was privileged to see the triple shadow transit on Jupiter. She came up just the right time. There's only about a 25-minute period. The last moon shadow came on. The other one was about to move out. So a year later, I was out in front of my house again, this time with a tripod and a camera. And I was trying to photograph my lighting for my website. And there have just been all these stories on Nextdoor, like, watch out, people are casing your houses. Sometimes they're photographing them, and be careful, look out for criminals out there. So here comes the constable car while I have my tripod out. And so I went up to it. I said, don't worry, it's my own house. I'm photographing. And then I hear Officer Rodriguez. She said, I remember you. You're the one who showed me Jupiter last year. So Jupiter's moon saved me, I think.
There you go. That's fantastic.
Clearly, you have a record with the local police.
Right.
All right. Well,
anyway, I was very happy she remembered me.
Absolutely. I'm going to try to avoid that trouble. But again, Chris, thank you very much for this wonderful presentation. Debbie, thank you for everything that you do to make sure that we have a wonderful novice program month after month. And before we leave, I just wanted to kind of share this. Hopefully everybody can see my desktop. Chris, I think you said the Rolls-Royce of planetary imaging telescopes is Hashi. Yeah, so I mentioned this at last month's meeting. We were the recipients of a generous donation by Candace Williams, and we have a 6-inch Takahashi at our observatory in Columbus, near Columbus. And so this is being installed right now. We're working through all of the kinks and bugs and everything else like that. But this is going to be available for all of the HAS members who want to use it and do imaging with it. It's wonderful for things other than planets as well.
What mount? What's the mount?
I don't know, to be honest with you. So that's something that we can ask Chris over, because I know they're using another mount right now. But the mount was donated. I want to say it's Paramount NX or something to that effect.
Yeah, I was going to say it looks like it might be a Paramount.
Yeah, I'm pretty certain it's a Paramount. But so when you add the value of the telescope and the mount itself, like I said, it was a very generous donation. We're ecstatic that this is part of our collection at the observatory for all of our members to use. And we're hoping to, like I said, for those who go through the training, we'll have access to this to do their own imaging. And we will actually be doing some live streamed public star parties, just like they do over at the McDonald Observatory as well. So look for that. And like I said, I just wanted to share that because that came up in tonight's presentation.
Yeah, and, beautiful thing.
Absolutely. And then lastly, we have a meeting tomorrow night. I don't know if you can see the transition of the screen there, but if you can't see my PowerPoint, our meeting is going to be at 7 p.m. It is a Zoom-only meeting. We are not, for the foreseeable future, going to be doing any in-person meetings just because of some timing issues over at the Mendenhall Center. They're looking to start closing earlier, and it'll be really tough for us to kind of squeeze that in. But we have a wonderful presentation tomorrow night. We're going to kind of continue the theme of imaging and those kinds of things that Chris alluded to. We're going to have a presentation about electronically assisted astronomy, not astrophotography, electronically assisted astronomy by Carlos Maria Orillo and Jeff Lepp. So that should be a wonderful presentation. We've got a lot of announcements too. So if you're able to make it, please do so, because we've got some exciting events that are coming up for the Houston Astronomical Society. So as always, if you're on social media, give us a like and a follow, because that allows us to do other things that you can do if you don't have a lot of likes and follows. And if you do have any questions for us, please send us an email, info@astronomyhouston.org, and we'll try to get those answered for you. But this presentation is recorded, and I hope to have it up and available for everybody to watch or rewatch sometime before the end of the weekend. So thank you very much.
Joe, yeah. Is there any way, is there a way to make the presentation available? I know there's a couple of handy charts, in particular, the one on the filters that I thought would be useful for people.
Yeah, we can do that. Absolutely. If you want to send that my way, I'll put it up on a Google Drive or the website or something like that.
All right.
To everybody.
I'll send you an Adobe version of it. They're smaller. So.
Perfect. Absolutely.
Okay. Excellent.
Great, everybody. Well, thank you very much for joining us again, and we'll see you tomorrow night. Have a great one, everyone.